Chapter 7.5 Solving Polynomials in Factored Form. A polynomial is in factored form when it is written as a product of factors. So I can give you an example of a very simple number. When you write any number like, for example, 12, then 12 is a number. And when you write the 12 as 4 times 3, then it becomes a factor form because you can write 12 as factor of two numbers, 4 and 3. So 4 times 3 is 12. So this part is called factor form, when you can write a number into two factors. For standard form, write in standard form descending order. So you're going to write this polynomial in descending order. It means the highest exponent should be in the front and then next to the power 1 on the back. So what you're going to write here is x squared, negative x squared plus 3x. And for the second one, you're going to write it down x squared plus 5x minus 24. So that's your standard form. When you write this equation into factor form, so for example, this is first term, this is second term, and you can take out the GCF out from these two. So the GCF of these two terms is x. So when you factor the x out, you get inside here 3 minus x. So that's called factor form, which means that this can be written as x times x minus 3. X times x is x squared and x times 3 is 3x. When you write the equation into factor form, you can write it x minus 3 times x plus 8. And when you do the FOIL on that, you can get the equation this one. So this is a standard form, and you write it into multiplication of two or more numbers or factors is called factor form. When one side of an equation is a polynomial in factored form and the other side is 0, you can use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are called roots. Means when you have this one equal to 0, then you can solve it for x, and then those x values are called roots. Key idea for zero product property. If the product of two real numbers is 0, then at least one of the numbers should be 0. For example, you have a two number if a and b are real numbers and product of a and b becomes 0, then you should think that either a is 0 or b is 0. That's why the product becomes 0. Example number 1, solving polynomial equations. Solving means that you're going to find the unknown variable. So the unknown variable in this one is x. So you're going to solve for x by using the zero product property. The zero product property was that if a times b equals 0, then a equals 0 or b equals 0. In this case, we have x times x plus 8 equals 0. So it means then you're going to put x equals 0 or x plus 8 equals 0. So which means either x equals 0 or when you subtract 8 on both sides, x equals negative 8. So either x equals 0 or x equals negative 8. Now you're going to plug it in to see if that is true. So you're going to plug it in x equals 0. So first you're going to use x 0 and you plug it into the main equation. So the given equation was x times x plus 8 equals 0. Now you know that the x equals 0. You're going to plug it in here. So you're going to use x equals 0. 0 times x plus 8 equals 0. 0 times anything is 0, so this becomes 0 equals 0, which is true. Now you're going to use again the given equation, and you're going to use x equals -8 and plug it in here on both the x values. So you can get -8 times -8 plus 8. -8 times 0 is 0. So 0 equals 0, which is true. In this case, I forgot to put 0 over here, so this one is also 0. Ultimately, 0 times 8 is 0. So when you use x equals 0 and plug it in for x value, you got 0 equals 0. And when you got x equals -8 and plug it in here, you got 0 equals 0, which is true on both the cases. Example number 2, solve the equation x plus 6 times x minus 5 equals 0. Solve the equation means that you're going to solve for x. So you're going to put the x plus 6 equals 0 or x minus 5 equals 0 using a property, zero product property, which means a times b equals 0. Either a equals 0 or b equals 0. So we're going to solve for x. Subtract 6 on both sides. So you get x equals -6. And add 5 on both sides. You get x equals 5. Now we're going to check these one by one. The original equation is x plus 6 times x minus 5. And first of all, we are going to choose x equals -6. So we're going to plug it in. X equals -6 for x. So you got here 0 and here you got 11. So 0 times -11 is 0. 0 equals 0, which is true. Now we are going to check the other value of x. And the other value of x is 5. So we're going to plug it in 5 for x. So you get 5 plus 6, 5 minus 5. So that's going to be 11 times 0. 11 times 0 is 0 and 0 equals 0 is true. So which means that these values of x are the correct values of x. So in order to make the factor multiplication of these two factor equal 0, either x should be -6 or x should be 5. Now you're going to try problem number 1, 2, and 3 and pause the video. And then we're going to go over on these together. So for number 1, you're going to put the x equals 0 or x minus 1 equals 0. So when you solve it, you get x equals 0 or x equals 1. So in order to have this product, x times x minus 1 equals 0, you should have either x 0 or x equals 1. For this one, you put them equal to 0 one by one. So 3t equals 0 or t plus 2 equals 0. Divide by 3 on both sides, you got t equals 0 or t equals -2. In this case, a times b equals 0 means either a equals 0 or b equals 0. Then you're going to solve for z by using opposite operation. So plus 4 on both sides, you got z equals 4. And -6 on both sides, you got z equals -6. In order to get the product equal to 0, either z should be 4 or z should be -6. Now we are going to discuss example number 3, modeling with real-life applications. So what do you see here? You see this graph, and this is called the parabola graph. This type of graph you get when you have an equation with the second degree or two factors. Similarly, like x times x, you would get a x square. So it's a second degree equation. or we call it as two factors, so 2x values. Whenever you have 2x values or two factors or second degree equation, you're going to get the graph that looks like a parabola or a U-shaped graph. The arch of a fireplace is shown to the left, and this is the equation of this arch. The x-axis represents the floor. Find the width of the fireplace at floor level. To do this, we must find x-intercepts. X-intercepts mean we're going to find the x values. So for that, we're going to plug this y equals 0. So we're going to find the x-intercept. So for that, we're going to put the y equals 0. And this becomes 0 equals 1 over 9, negative 1 over 9, x plus 18, x minus 18. So this cancel with the 0, because either you can say that you're dividing with negative 1 over 9 on both sides, so becomes 0. So we get here at the end is 0 equals x plus 18, x minus 18. Going to apply the zero product property, which means you're going to put the factors equal to 0 one by one. So what did we do here? We divided 1 over 9 on both sides, and whatever number you divide with 0, it becomes 0. A times b equals 0. You got either a equals 0 or b equals 0. And then you got two x values. So here you're going to subtract 18 on both sides. You got x equals negative 18. In this case, you're going to add 18 on both sides and you get x equals positive 18. So these are the two x-intercepts you got from this equation. Now you're going to find the maximum height. So this is the maximum height. Find the maximum height of the fireplace. To do this, we find y-intercept. So this point that we're going to find, and you can see that this is a y-intercept. So we're going to find y-intercept. To find the x-intercept, you can plug in y equals 0. And to find the y-intercept, you plug x equals 0. So that's the review. So the equation we have here is y equals negative 1 over 19 x plus 18 x times x minus 18. Now we are going to look for y-intercept. So to find the y-intercept, we're going to plug x equals 0. So I'm going to plug it in. X equals 0, x equals 0, and we get here is negative 1 over 19 times 18 times negative 18. So now we're going to multiply 18 times negative 18. So 1 over 19 remain as it is with negative sign. 18 times negative 18 is negative 324. Negative cancel. 324 divided by 19, what do you get here is equal to 17.05. So which means that this height is 17.05 from the floor level. Now you're going to do these more practice problem in your notebooks, and that's going to be your homework. You're going to do the level 1, 2, and 3. So mostly if you are doing level up to level 2, that is fine. If you're skipping level 3, that's perfectly fine. And for that, you can see that we do not have enough space here. So we're going to do those on a notebook or another binder paper. But we can also do the level 3C problems here. So you try the level 1 and 2 and 3 if you like to. You're definitely doing level 1 and 2, but you try level 3 if you like to. Next question, level 3C. The entrance of a tunnel is modeled by y equals negative 11 over 50 x minus 4 times x minus 24, where x and y are measured in feet. The x-axis represents the ground. You're going to find the width of the tunnel at ground level. So this is called width, which means that you're going to find the x values. So you're going to find the x value by putting the y equals 0. So y equals 0 here. Negative 11 over 50 go on the other side and become 0. Now you have 0 equals x minus 4 times x minus 24. You put them equal to 0 one by one because of the zero product property. You got x equals 4 and x equals 24. So for example, if this is x equals 4 and this is x equals 24, it means that the distance should be 24 minus 4, and that's 20. Now you're going to find the maximum height. It means you're going to find the y value by putting the x equals 0. So here the x equals 0, x equals 0. You got here negative 4 times negative 24 is 96. Negative 11 times 96 divided by 50, you got negative 21 minus negative 21.12. So the height is negative. It means it's under the underground, and it is negative 21 feet from the ground. Negative 21.12 feet from the ground level.